Now we're going to be looking at 1.51a again, and I'm going to finish working the rest of these problems. And once you get finished working, copying down these and correcting your paper, I want you to glue this into your composition book so you can use it as notes. Now, when I look at number 2, I see that this is a mapping diagram. So the first thing I'm going to do is write domain above the X and the range above the Y. Now, I can look at this mapping diagram and I can look at this and write it as a table or T-chart. I see that my 6 goes to the 3. My 6 also goes to a 5. Now notice I have a V shape right here. That's very important. So as soon as I have a V shape right here that looks like a V or a W shape or anything like that, then if there's more than one line going to a number on the left-hand side, then it would be no, it's not a function. And as you can see right here in the table, I have the 6's are repeated, so it's not a function. The rest of these numbers only go into one, each input right here. This is also your input, and this is your output. You can only have one input going to one range or one output over here. And you see 6 is going to the 3 and the 5, so it's not a function. Now, when I look at these others right here, I could see that the 7 goes with the 4 and the 8 goes with the 1 right here. Now I'm going to take off some of this right here, and I'm going to look at the domains right here, and I see that these are already in order, so I'm just going to copy them down. And since these are individual points, we write them as individual points right here. So I have my numbers 6, 7, and 8 in order. Now come over here to the range. If a number's repeated, you're only writing it down one time. And these numbers right here are in order from least to greatest. You see that it goes to a negative, or most of them, a -4, so we've used that. Now we have a 1, and then a 3, and then the 5. So these are in order from least to greatest. Now, so when we're looking at to see if this is a function or not, all you're concerned with is over here on the left-hand side, the domains. It does not matter about the ranges. You can have the same number over there. It will not matter. Now, look at number 4. On number 4, you see that you have another mapping diagram. This is your X and this is the Y, the domain, write this down, and the range. So when I have these, I see that I look at number 4 and I see that there's only one line going to each number from the domain to the range. One input only is assigned one output. And when we were looking at number 2 right here, we see that the 6, it was assigned more than one output right here. You saw that V shape. So if we have that V shape, then that is not a function. Here you just have one line going to the number 3. So since you only have one line going to there, then you know that yes, it is a function. Now I'm going to write these in order right here, and I see I have 5, 10, 15, 20. These are in order. And the 3, -3, is repeated again and again, but we're only going to write it down one time. So if I were to write this in a mapping, this mapping diagram as in a T-chart, this is what it would look like right here. T-chart or a table. 5 goes to -3, 10 goes to -3, 15 goes to -3, 20 goes to -3. And since these -3's are repeated, you're still only going to write it down one time. But the 5, 10, 15, and 20 are not being repeated, and this is your domain. That's how you're going to tell if it is a function or not. Now, look at number 6. On number 6, since this is one continuous line going across, since it is continuous, you're going to write it in interval notation. Interval notation can sometimes be called blueprint. Some teachers even call it inequality notion, because you're looking at number 5. You're working with inequalities, less than or equal. Now, when I look at this right here, I'm going to go ahead and see if it's a function or not. And when I draw the vertical line right here, I'm going through 2 points at a time on this one line. And so since I'm going through 2 points at one time, it is not a function. I'm going to take the vertical line test off. Now I'm going to go ahead, and since we see that there are definite stopping points on each one of these, it is one continuous line, I'm going to go ahead and put X, and I'm going to put less than or equal, because I see these are solid points. There's a definite stopping and starting points. So I know that it's going to be written this way. And my endpoints will be included. Now I'm going to look over here. The first thing I'm going to do is check for my domain. And when I'm checking for my domain, I start on the left-hand side. I'm going to lay my pencil down sideways, and I'm going to come in from the left-hand side. And when I lay it down sideways, the first thing that I counter right here is this solid point right here. And so I know it's a definite stopping point or starting point. So I have 0, -1, -2. So I'm going to put a -2 right here. Now I'm going to do the same thing to the right-hand side. Come in from the right-hand side, lay your pencil sideways, and the first thing that you come across is this solid wall right here, the solid point. So we have 0, 1, 2, so the other side is at 2. So this figure goes from a -2, less than or equal to X, less than or equal to 2. Now I'm going to change my colors, and I'm going to come in from bottom to top. So when I come in from the bottom to top, I'm going to take this right here, and I'm going to come in this direction right here. That's not easy to see. So let me change colors again. And I'm going to go in this direction at the bottom. So lay your pencil sideways, and as I come up right here, laying it sideways, the first thing I encounter right here is this solid wall, which is this point. And so I know it's a definite starting point. So I see that this is 0, -1, -2. So I'm going to put a -2 right here. Now I'm going to come in from top and go to the bottom. Lay your pencil sideways, and as you do, the first thing you're going to encounter right here is this point, this solid wall. So when I come down here, this point, this right here is at a 1. So I'm going to put a 1 down. So this is continuous, and when you have a continuous graph, then you must write it in interval notation like we did right here on domain and range. Now, look at number 7. Number 7 will be written as discrete because these are individual points right here. Number 5 and 6 were continuous, so we wrote it in interval notation or inequality notion. Now, when I look at this is your X, which is your domain, your range, that's your Y, and this is the range. So I look at this right here, and the first thing that I see is we have a V shape right here, going from a 3 to a 1, going from 3 to 1 and 3 to 0. So I know that since I have this V shape right here, it is not a point, so I'm going to put no. Now I'm going to take these right here. I'm going to look at my ranges right here, my domains, and I'm going to write them in order. And then remember, it's going to be written as discrete because they're individual points right here. So I have, and I'm going to write them in order, 3, 5, 7, and 9. Now I'm going to do the same thing to the ranges, and when I write them in order, I'm going to go from least to greatest. And remember, these are individual orders, so I go 0, 1, 9, 33. Okay? Now, I could have written these. These are the same thing that if we had a T-chart right here or a table. You see the 3 goes to 1, 3 goes to 0, 5 goes to 9, 7 goes to 9. Let me change this. So 7 also goes to 9, and 9 goes to 33. This is what it looks like if you had to write it in a T-chart or a table. You will see that the 3's right here were being repeated. So it is definitely not, and it is not so it is not a function. Now, look at number 8. Now, number 8, you see that on number 8, that there is this figure right here is continuous, and since it is continuous, I'm going to write continuous. So I know that this has definite stopping points. Sometimes if it was all real numbers, you would have an arrow on the end. But notice we do not have an arrow on the end. So this is a definite stopping point. Starting point and stopping point. So I know that this is going to be written in interval notation. I'm going to write my X right here, less than or equal in front of it. My Y, less than or equal. Let's go ahead and do the vertical line test. So when I draw the vertical line test, I see that this is only going through 1 point at a time. So we're going to put, yes, it is a function. Now I'm going to take these points off, and then I'm going to lay my pencil sideways, if I can get this to erase. And I'm going to come in. When I do, this is my X, which is my domain. And this is my range, which is my Y. Go ahead and write those down. And so when you have these, you're going to come in from the left-hand side. So when you come in from the left-hand side, lay your pencil sideways. And when I lay my pencil sideways, the first thing that I come to on this side right here is this point right here. I'm going to come up here to the x-axis, and I'm going to count. And I see it's 0, 1, negative 1, negative 2, negative 3, negative 4. So this goes over to a negative 4 right here. Now, lay your pencil sideways on the right-hand side, and as you come across right here, the first thing that you encounter is this point right here. And I see that this point is included, that it's a solid circle right there. It's a solid line. So it's 0, 1, 1, 2, 3. So I'm going to put a 3 right here. Now, I'm going to do the same thing for my range. I'm going to come in from the bottom, and I'm going to erase these lines right here so that we can see much better the figure. Now, when I come in from the bottom, I see this is the lowest point. So I'm going to come in this way from the bottom, lay your pencil sideways, and I see the first thing that I encounter is this point right here. This is included. So when I count, I have 0, 1, negative 1, negative 2, negative 3. So I'm going to put a negative 3 here. Now, I'm going to come in from the top this time, and I encountered this figure right here at this point, right here, and I'm going to count. I have 0, 1, 2, 3, 4. So this goes to a 4. Now, this is continuous. It is written in interval notation. Look down here at number 12. On number 12, I see that these are not individual points. This is continuous. So I know that it is going to be written in interval notation, just like I did with problem number 8. And I see that these are solid points right here. That means that this point, which is at 1, 1, 2, and this point right here is at 3, 4, is included in this line because it is solid points. So I'm going to erase this now, and let's go ahead and start writing this in interval notation. And I'm having trouble to get this to erase. There we go. So I'm going to draw the vertical line test, and I see this is only going through 1 point at a time. So I know this is a function. Now I'm going to come back over here, and since this is my domain, your X is your domain, the Y is your range, I'm going to take my pencil, and I'm going to go to the lowest point right here, and I see that the first thing that I come to when I lay my pencil sideways or looking at this point, I see that this goes from a 1, and we forgot to go ahead and put this. So I have less than or equal Y, less than or equal. So this comes down to a 1. So it begins at a 1, and I come to the highest point, and this begins at a 3. So the domain right here is 1 is less than or equal to X, less than or equal to 3. Make sure your smallest number is on the right-hand side. This next one, I see that I'm going to find the lowest point of this figure right here, and on the range. So when I come up right here, I see that this is the lowest point, and I'm going to come over here to the range side. So it starts at a 2 and it ends at a 4. So this is a continuous graph. You write it in interval notation. Now this next one, when I look at this one right here, I see that on number 15, B, I see that I'm going to check, I have a 1, 2, 3, 4. So when I look at those numbers, the first one in each ordered pair, which is called a relation, this is your domain, 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 domain. So look at it, I have 1, 2, 3, 4. None of those are being repeated, so we say yes, this is a function. Now, another thing that I'm going to go ahead and do, since this is my domain that I have circled right here, I see that none of these are repeated, so I'm just going to write them in order. 1, 2, 3, 4. Now, I'm going to, let me get this to writing again. I have a 4. Now I'm going to change colors, and then when I do, I'm going to mark these out right here. So I see I have a 2, -1, 2, -1. So these are my ranges. I'm going to label these as ranges, or my Y's. And so I'm going to put them in order. And I see that -1 is the smallest, and I have this written, it's repeated twice here, but I only write it down one time. Then I see I have a 2 and a 2, so only write it down one time. Now, we have completed that, and on number 16, I noticed that on number 16, that when we wrote the range, I forgot to include right here, so check your answer right here. On the range, it goes from a -8, less than, because any infinitive, whether it's positive or negative, you can never, never, ever find the end of it. So it's like a rainbow. If you saw a rainbow in the sky, you can never find the end of the rainbow. So it's not equal to it. So anything that's written as infinity right here will never be equal to. So it's less than right here, but no equal to. On this side, when we did the range, notice that when we brought the pencil down and turned it sideways, the first thing that we encountered right here was at the point, the 3.5, and since it does have a definite stopping point, then it should look like this: less than or equal, less than or equal right there. Make sure that you write that down. So now this paper right here should be completely finished right here. So go through, make sure everything is correct. I have made 2 videos on everything now. So I want you to glue this into your composition book.